Hello everyone. Today I'll be talking about SR latch. SR latch. We can use both NAND gate or NOR gate, but here I'll be using NAND gate. Using NAND gate. So NAND gate has the characteristics. Whenever any input is equal to 0, the output will be 1. Output will be 1. Okay, fine. So the circuit of SR latch is somewhat like this. You have two NAND gates. You have one control input is S. The second control input is R. So there is gate number 1. This is gate number 2. In gate number 1, the control input is S, gate number 2 control input is R, and the second input for both the cases we take like this, both the gates. And output, this is the input and output is also here. So if present state is Qn, then next state will be Qn plus 1. This is how we represent it. Now this is, if this is Qn, here it will be the complement of this. So Qn and next state will be Qn plus 1 bar, right? This is Qn bar. They are complement of each other. They are also complement of each other. Fine. So S and R. Two variables, so there will be 4 possible combinations. S, R, and the output will be written as Q of n plus of 1 and Q of n plus of 1 or when 0, 0, both gate will have output as 1, which is invalid because we need the output, we need the output as complement of each other. If Qn is 1, Qn bar should be 0. If Qn is 0, Qn bar should be 1. Right? So this is invalid case. When S is equal to 0, R is equal to 1, definitely the first gate has the input as 0, so the output will be 1. Right? Okay, now let us analyze it. So here you have, this is 0, so this gives you 1. So this 1 and R is also 1. 1 will give you 0, right? So this will give you 0. When it is 1 and 0, so R, the second gate is getting 0, so output will be 1, right? So then 1, so this is 1 and 1. This is 1, right? So 1 will give you 0. So this gives us 0, right? Now 1. Here the interesting thing happens. You see, when S and R both are 1. Now it can be if both are 1, because in this 3 cases we have seen some zeros are there. Inputs are 0, 1 or both, isn't it? So we know what will be the output, because if 0 is the input to a NAND gate, output will be 1 definitely. Okay, now if both are 1, then in that case what happens? I am assuming that Qn is equal to 0, right? Qn is equal to 0. S and R both are 1. Okay. Now we see. Qn is equal to 0. S and R both are 1. This is 1. This is also 1. Qn is equal to 0. One input is 0 to get 2. So output will be 1. So Qn bar will be 1, right? Qn plus of 1 bar. So this implies qn plus 1 bar is equal to, because one input is 0. So now what happens? Qn plus 1 bar is 1. This 1 will go and this will be the input to get 1. So here S is already 1 and there is also 1. 1, 1, this will give you 0, right? So now we are getting this as Qn plus 1 as 0. So what do you find? The present state was 0. Present state was 0. And next state also we are getting it as 0. So this is a kind of memory, acting as memory, right? When S is equal to 1 and R is equal to 1. When it may happen that Qn is equal to 1, isn't it? These are the only two possibilities. Either Qn will be 0 or Qn will be 1. So suppose Qn is equal to 1. In that case what happens? Now let us see the second. Here. In this diagram, Qn is equal to 1. So R is 1, Qn is also 1. So the gate 2 has both the input as 1. So output will be 0, right? So Qn plus of 1 bar will be Qn plus of 1 bar will be 0, right? Now see. Qn plus of 1 bar is 0 means this gate number 1 will get 1 input as 0. So now the output will be 1. So Qn plus of 1 will be 1. So Qn plus of 1. So present state and next state. Both are present state and next state. Both are same. So they are acting as a memory. So when Qn is 0, you are getting Qn plus of 1 as 0. When Qn is 1, you are getting Qn plus of 1 as 1. So that means this is Qn and this is Qn bar. Right? So this is acting as a memory. This is all about, this is the truth table of SR latch. And this is all about SR latch. Hope you have understood it. If you like it, please press the like button and please subscribe the channel. If you have any suggestion, you can very well comment in the comment box.